All right, so this is the tutorial video for the balancing chemical equations introduction. So I'm going to go ahead and show you an example with the skeleton equation that was given to you in the introduction reading. So zinc plus hydrochloric acid yields zinc 2 chloride and molecular hydrogen. So the first step is to assign a color for each of the ions that are participating in this reaction. We know how to break apart compounds into ions. So we can see here that we have just zinc. So I'm going to go ahead and make zinc blue. I have hydrogen. I'm going to go ahead and make that orange. And I have chloride, which I'm going to make green. Now you can assign any colors you'd like. There's nothing specific, or there's no particular reason why I made those colors. That's up to you. Just keep it consistent throughout each problem. So now that we've assigned a color, we're going to go ahead and build the atoms using the paper clips. So if I were to build zinc by itself, it only consists of one atom. So zinc would look like this, just a single blue paper clip. But if I wanted to build hydrochloric acid, I would have to take hydrogen and chloride, and I'd have to bond them together. So if I left them like this is just atoms kind of floating around, or dissociated ions. So I'm going to go ahead and bond them together by snapping them together. Now they're bonded, and I've created a hydrochloric acid molecule. So if I wanted to create this, that means I need one zinc with two chlorides. I've gone ahead and created that already. And then diatomic hydrogen looks like this, or molecular hydrogen looks like this, two paper clips bonded to each other. So now that we've built our molecules, we're going to go ahead and take an inventory of all of the atoms on the reactant side and all of the atoms on the product side. Over here, I only have one zinc. I'm going to go ahead and keep that in my tally. And I have one hydrogen, as well as one chloride. On the product side, I have still only one zinc total, but I have two chlorides and two hydrogens. So this is what our model looks like, and this is our tally at this point. So far, so good. Now, when we show a skeleton equation like this, it's not balanced. And the reason why we like to balance skeleton equations is because we like to show proof or support for the law of conservation of mass. Now, this doesn't show the law of conservation of mass. Why? Well, if you look here, we start with only one hydrogen and chloride, and then suddenly we end up with two hydrogens and two chlorides. And the law of conservation of mass tells us that matter cannot be created like this or destroyed. It has to be there the whole time. It just is rearranged. So we have to balance our equation to have the same number of reactants as products. So how are we going to do that? Well, first we're going to go ahead and inventory, which we already did, and we're going to balance the metals. So if we look at zinc, I have one zinc on the reactant side and one zinc on the product side. So this is already balanced, so I'm already done balancing it. I don't have to do anything with it. But if we look at hydrogen and chlorine, we go on to our nonmetals. We don't want to pay attention to hydrogen, so we're going to look at chloride. I only have one chloride ion on this side, the reactant side, but two of them on the product side. So I need to reconcile that difference. How am I going to do that? Well, a lot of people would just take a chloride ion and add it. But the problem with that is chloride doesn't exist like this on the reactant side. It exists in a molecule of hydrochloric acid. So instead of adding singular paper clips, you're only allowed to add molecular units. So I'm going to go ahead and add another hydrochloric acid molecule. When I do that, I'm going to re-inventory all of my atoms. I still only have one zinc each on the reactant side and the product side. But now that I've added this second molecule of hydrochloric acid, I now have two atoms of hydrogen on the reactant side, still two on the product side, and now two atoms or ions of chloride on the reactant side, and still two on the product side. So I'm going to update my tally to show that. Now this equation is balanced according to the tally. We have 1 and 1, 2 and 2, 2 and 2. So we are balanced. This successfully showcases the law of conservation of mass. But now we need to show it in the way we write our formula. Because I only have one atom for zinc, I would place a 1 as my coefficient in front of zinc. Because I only have one molecule of zinc 2 chloride, I would place a 1 in front of zinc 2 chloride. And because I only have one molecule of molecular hydrogen, I would only place a 1 in front of molecular hydrogen. But because I added another molecule of hydrochloric acid, and I have a total of 2, I have to show that with this coefficient by writing a 2. So this is actually our balanced chemical equation. But the problem with it is that we actually don't like to write ones. We're a little bit lazy in science. So we're going to go ahead and erase those. Now this is actually what your finalized balanced chemical equation would look like. And we know that it's supported by this tally.